This is a quick demonstration of Relate EnSQL, assert's latest addition to the Relate product family. We'll call it EnSQL for short. EnSQL provides standardized SQL access to enscribe data on non-stop systems both locally and remotely. This is achieved without modifications to your data files, system files or program files. There are no API intercept libraries or other tricks being used to enable the SQL functionality. EnSQL's primary local interface is a command line or shell program called EnSQL CI. This uses a database configuration file which defines a collection of enscribe files, along with the underlying formats of those files, which may be obtained from DDL dictionaries or COBOL source files. Once defined in EnSQL, they are all accessible as EnSQL tables. Demonstrations of command line interfaces aren't particularly exciting, so our aim is to get the point across in as concise a manner as possible. In this case, we're going to show EnSQL CI running in parallel with Relate Classic, our original data maintenance program for non-stop servers. Some may know Relate Classic using the name of one of its editions, such as Relate Plus or Relate 2000. We'll mainly just call it Classic for short. Those people familiar with Classic will immediately recognize the ancestry of EnSQL.
We're going to demonstrate the two products side by side using a shared demonstration data file that we deliver with the products. Both programs are run from the tackle command line. With Classic, we explicitly specify the enscribe file we're interested in when we open it. With EnSQL CI, we specify a database configuration file, which contains a collection of enscribe files treated as EnSQL tables. From the command line, the look and feel for both is very similar. With Relate Classic, we associate a DDL record format with the data file. With EnSQL, the format is part of the database configuration, normally loaded at startup. On the left screen we see all the field definitions, and on the right we see the list of EnSQL's visible columns. Let's see how many records are in the database. Relate Classic has an inbuilt count command to handle this directly, whereas with EnSQL we rely on standard SQL syntax based on the select statement. Now let's create a backup of the file we can use to track any changes we make. We'll do this in Classic by first using its X command to execute the fup file utility program in a background tackle shell. EnSQL CI has the exact same capability. We'll then use the copy command to copy the records to our backup file. The equivalent way of doing this in EnSQL would be to use an insert statement that references our original file using an embedded select statement. We'll now show the record content. Classic has its own list command, whereas, as you'd expect with EnSQL, we use the select command. In both cases, we've specified that all the columns are listed. We'll now update this highlighted record in EnSQL CI by using some of its field values we can see in the select expression. We'll change the value of the name field from John to Andrew. And we'll now list the records again on both sides to show the change. If we want to identify the differences between the files, then on Classic we can use its inbuilt compare command, which for key sequenced files such as this, will show the field-level differences. The SQL language has no such intrinsic capability, so identifying such differences would require explicit long-winded select statements to be built referencing all the columns.
Let's look at an output listing from an EnSQL CI session to get an idea of some other more advanced product features. We'll start with the data we've already seen. In particular, we're going to be looking at the last update field. In the original DDL, this was actually a group. The group contains a 64-bit Julian timestamp redefined by another group, containing a 16-byte indicator field followed by a 48-bit non-stop timestamp. The idea being that if the indicator field is 0, then this indicates that the 48-bit timestamp is in use, otherwise the timestamp is a 64-bit Julian timestamp. While the example is contrived and simple, The concept of redefined data with associated rules that indicate when the appropriate redefinition is to be used is very common with EnSQL data. EnSQL has the concept of hidden columns, which allows it to handle this situation and display the data appropriately. All the above fields are available as columns, though only one is displayed as part of a select asterisk statement. We can display the other columns by explicitly referencing them. Here the redefined columns last update 64, indicator 48 and last update 48 are explicitly specified in the select statement, and all their values are displayed. But now we have duplicated columns, which may not be desirable. To address this, we can use EnSQL's IIF function to indicate the conditions for displaying each column, by checking the value of the indicator 48 field. This demonstrates how field redefinitions can be handled and the data conditionally displayed. But in this example, the fields contain numerically coded dates, which are meaningless in their raw form. To resolve this, we can use other EnSQL functions. Here we are still conditionally selecting the column to display, but we are then using the appropriate function, either g_48 or g_64, to convert the values to something meaningful. We'll now show another example of where hidden fields are used. EnSQL automatically creates hidden fields to represent the key data in a record. This example shows the primary key data in the fields separately defined as join year, seek num and company code, can also be referenced by the hidden auto-created PKey field. The top example shows it being displayed, and the second example shows it being used in an expression. Talking about the primary key, here's a nifty feature that users of Relate Classic have asked for many times: the ability to update the primary key data of key sequenced files. In this case, we're using a very simple statement to compute the new value by using a numerical expression that references the original value, something else Relate Classic users have asked for. Our final EnSQL CI examples demonstrate one of the great powers of SQL, the ability to combine tables together. In this case, the two tables being combined have identical formats. In the first example, we are joining them on the hidden primary key column and selecting the combined result, where the join year is 12. We can see that in the first table the department is EGFKS, and the second it is EGFKS2. The result is presented as a single row. In the second example, we are seeing the same data presented as a union of the two tables. So, in this case, the rows from each table are listed separately.
Our final feature to mention is JDBC support. Using our provided library, all of the features we just discussed can be programmatically accessed via JDBC clients. This can be from any Java-supported platform, the OSS personality of Nonstop, as well as Linux and Windows. So this slide shows how we can have both local Java JDBC processes using EnSQL to directly modify the EnSQL data, as well as remote Java processes using our EnSQL JDBC library and server process on the Nonstop to do the same thing. We'll quickly demonstrate this JDBC operation, first with a custom Java client running on Windows. Here we're using this URL to connect our custom client to the JDBC server process on a remote Nonstop server. This last part of the URL indicates the database configuration file to which we want to connect, which in this case is a logical define name known by our server. Running the client produces a bunch of output. The first part is a simple listing of the rows in the table. The second part is demonstrating a TMF-protected update to a couple of the rows. We're updating these last two rows to specify the name as Joe, and then listing the rows while the transaction is still active. At that point, we're rolling back or aborting the transaction and listing the data again to show the values have reverted. It should be noted that we're not limited to custom JDBC code, but also standards-compliant third-party tools. For example, here we're showing a free graphical client called dbeaver. If we look at this database connection, we can see it uses the same connection URL as earlier. In particular, we're using the same define name for the database configuration file. If we now make the connection to the server, we can see a tree view of the SQL objects. Expanding the tables, we can see there are 4 tables defined. Now expanding the table TA, we can see the columns we saw in the last example. We can now have dbeaver generate a query so we can view or modify the data. Let's modify this last row. We'll set the join year to 10 and the name to Joe again. We'll save the data and then refresh it from the server and see it re-sorted with our modified row now at the top. There are a couple of other things to point out here. First is that you may recall that join year is part of the primary key, so this change, in the background, actually deleted and then reinserted the corresponding enscribe record. The other is that we know from the previous custom JDBC client demo that this file is TMF protected, so the server automatically performed the TMF transaction for us. Let's wrap things up.
To summarize, Relate EnSQL significantly increases the data maintenance capabilities of the Relate product family. EnSQL CI provides shell access consistent with both the non-stop look and feel as well as Relate Classic, while being compliant with SQL standards. It provides standardized JDBC access to enscribe data from both local and remote clients. Finally, you are not being entirely force migrated to SQL in order to gain SQL access, like some other products. Your data doesn't have to change.